Hello there, and welcome. I'm glad you're here. Maybe your day is finally quieting down, or maybe you're the kind of person whose mind prefers to drift off with something bigger than bedtime stories. Something wide and weightless, something made of stars. Whatever brought you here tonight, you're in the right place. There's nothing to solve, no pressure to understand. Just breathe easy. Let the tension fall out of your shoulders. Let your mind tilt upward, like a telescope aimed at nothing in particular. You're floating now, gently, in the space between comfort and curiosity. Because tonight, we're not trying to answer every cosmic question. We're simply going to marvel at them. 100 strange, beautiful, sometimes haunting truths about the universe. Some are ancient, some are new, some feel impossibly far away, but they all live out there, or maybe in here, somewhere beneath the surface of thought. As you begin to unwind, we'll slip into this starlit current together, past the galaxies, past the noise, into the quiet, radiant unknown. Now take a deep breath, let your day drift away, and let's travel together into the quiet corners of the universe. In the beginning, there was no bang. Not really. The Big Bang was not an explosion, but an expansion, not a blast from a central point, but a stretching of space itself. And it didn't happen in one spot surrounded by empty darkness. It happened everywhere, all at once, because space itself was being born, and it's still happening. Even now, the fabric of the universe is expanding, quietly, constantly, invisibly stretching in every direction. You might imagine galaxies racing away like sparks from a firework, flung outward into the void. But it isn't quite like that. The galaxies aren't flying through space. They're being carried by it. Imagine dots on the surface of a balloon, and then imagine the balloon inflating. The dots don't move themselves, but the space between them grows. Every second, the universe gets a little larger. Every moment, the galaxies drift farther apart, not because they're in motion, but because the space that holds them is expanding like soft, invisible taffy. This idea was once a shock. Before the 20th century, most people believed the universe was static, unchanging, eternal, perhaps infinite, but certainly not moving. Then came Edwin Hubble. He looked into the sky and saw something strange. The light from distant galaxies was stretched toward the red end of the spectrum, as if they were moving away from us. This redshift was more than a trick of light. It was a signature of motion, a cosmic Doppler effect. And the farther the galaxies were, the more redshifted their light became. Hubble had uncovered a pattern, and that pattern became a law. The universe is expanding, and it has been since the beginning. But that was only the first surprise. For decades, scientists thought the expansion might be slowing down. Gravity pulls things together, after all. So, even as the universe grew, it made sense to imagine that growth, gradually, softening, slowing, perhaps even reversing one day. But when astronomers looked closer, measuring light from distant supernovae, ancient explosions that serve as cosmic mile markers, they found something deeply unexpected. The expansion wasn't slowing, it was speeding up. The universe wasn't just stretching, it was accelerating. This mysterious acceleration has no clear cause. We call it dark energy, not because we understand it, but because we don't. It seems to fill space like a pressure, pushing outward, counteracting gravity, stretching the cosmos faster and faster as time goes on. The more space there is, the more dark energy there seems to be. And the more dark energy there is, the faster space expands. It's a runaway process, quiet and invisible, unfolding across billions of light years, changing everything. When you look up at the night sky, it doesn't feel like anything is moving. The stars seem still, the constellations unchanged, but that stillness is an illusion. Beyond what your eyes can see, galaxies are retreating. Not just some, but nearly all. Even the most distant objects we can detect are slipping away, their light stretched thinner dimmer, redder, with every passing moment. Some are already gone, not in reality, but from reach. The expansion of space means that light from certain galaxies will never reach us, no matter how long we wait. They're still out there, but their messages are swallowed by the stretching of space, like voices in a room growing too large to carry sound. And the future? It depends. If dark energy stays constant, the universe will keep accelerating forever. Galaxies will drift so far apart that their light no longer touches. The night sky will go dark, one galaxy at a time, until only silence remains. If dark energy grows stronger, the stretching could tear even atoms apart, a scenario called the Big Rip. Or perhaps it will fade, and the cosmos will slow again, pulled back by gravity towards some unimaginable ending. But for now, expansion reigns. It's hard to picture this. Our minds aren't made for it. We live in a world where movement requires effort, where distance means travel, and where empty space is simply a background. But in the universe, space is not empty. It's dynamic. It has rules and structure and behavior. And in that structure, the galaxies drift, not through the void, but with it. There is no center, no edge, no explosion throwing pieces outward. There is only more space, unfolding. This isn't just science, it's something deeper, something poetic. The idea that the universe is not done growing, that it continues to expand beyond our reach, beyond our vision, beyond our comprehension. It invites wonder. The galaxies we see are not fixed like points on a map. They are moving pictures in a film still playing. Every image we take of the sky is a snapshot of something already gone, already changed. We are surrounded by motion, drift, and the gentle stretch of time itself. Even our own galaxy, the Milky Way, is adrift in this flow. It's moving, not through a fixed stage, but within an ever-changing frame. And though gravity binds us to Andromeda, bringing us slowly closer in a future collision, the space around that meeting swells with expansion. We live in a bubble of motion nested inside a vast sea of acceleration. If you could float above the universe, outside it somehow, you would not see an explosion frozen in time. You would see a fabric being pulled from every corner, a silent unrolling of space, a web stretching wider and softer with every passing second. But there is no outside. There is only within. Only this. And here, within this universe, you are drifting too. You don't feel it, but you are part of the motion. Your atoms, your heartbeat, your breath, all wrapped in this slow and steady expansion. The light from your body joins the light from stars, stretching outward into the future. It may never be seen, but it still moves. The universe is not done. It's not finished, and neither are you. You may have imagined it at some point, even as a child, the center of the universe. A single glowing point where everything began, where stars burst out like sparks and galaxies flung themselves across the void, a place you could point to if you only had the right map. But the universe doesn't have a center. There's no secret middle, no glowing heart of everything, not in space, not in time. And yet, everywhere you look, it appears the same in all directions. That isn't a contradiction. That's the shape of reality. When the universe was unimaginably young, less than a trillionth of a second old, it went through a moment of rapid, wild inflation. Not a slow drift outward, but an instant expansion that stretched space itself faster than the speed of light. It didn't happen from a single dot into an empty stage. There was no stage. Space didn't expand into something. It was the expansion. Every point stretched, every gap widened, and when that inflation slowed, what it left behind was something astonishing. A universe that looked nearly identical in all directions. Smooth, balanced, and consistent, even billions of light years apart, as though it had always been stitched from the same cloth. This is one of the quiet marvels of the cosmos. No matter where you are in the universe, No matter which way you turn, the large-scale structure looks remarkably similar. The background radiation, the ancient afterglow of the Big Bang, comes from every direction, and it's almost the same temperature, no matter where you look. The galaxies, too, are spread out in vast filaments and walls, but no great cosmic pattern points to a central place. There is no signpost labeled origin, no privileged seat, no cosmic throne. And yet the illusion of a center is easy to fall into. From Earth, it looks like everything is moving away from us. The farther a galaxy is, the faster it appears to recede. It's tempting to imagine this means we're at the middle of it all, watching the universe flee from our position like ripples from a stone. But if you lived in a galaxy billions of light years away, you'd see the same thing. Everything would still be moving away. The farther it was, the faster it would seem to go. Not because you're at the center, but because there is no center. Every point in space is receding from every other point. It's not a journey outward. It's an unfolding. This is difficult to picture, because we're used to things moving through space. A bird through the sky, a car down the road, even planets around a star. But in the expanding universe, it's space itself that is growing, not objects flying apart. Galaxies aren't being flung into the void. They're embedded in space, like raisins in dough, and the dough is rising. From any raisin's point of view, all the others seem to move away. But there's no single raisin at the center of that motion. There's just expansion. And what about the edge? That too is an illusion. There is no wall, no border you could reach, no boundary you could touch. The observable universe, the part we can see, is limited by how far light has traveled since the beginning. But beyond that horizon, space continues. We don't know how far. It might go on forever. The edge is not a place. It's a limit of vision. Like looking out over the ocean at night, you see only so far, but the sea does not end there. The idea of a central point appeals to us for reasons that have nothing to do with physics. We want there to be a special place, a source, an anchor. We want to believe that somewhere, long ago, in some perfect center, it all began, and from that singular spot, the universe grew outward. But the truth is more strange and more beautiful. The beginning didn't happen in a location. It happened everywhere, because at the moment of creation, space itself was born, and so every point in the universe was once the origin. That includes where you're sitting now, this quiet place, this breath. The atoms in your hands trace back to that same beginning, not as pieces hurled from a central blast, but as parts of a fabric that has been stretching since time began. You are not at the center, but you are part of it all, a thread in the vast weaving of space and time. You are not apart from the expansion. You are carried by it. Somewhere out there, in every direction, galaxies are moving away, each one whispering the same story, that the universe is not built like a spiral, or a sphere, or a shell. It is built like something stranger, a structure without a center, without an edge, expanding not outward, but everywhere at once. And that story includes you. You may not feel it, but you are drifting, not just on a planet spinning in the dark, not just around a star in a spiral galaxy, but through a cosmos that is still unfolding, still stretching, still becoming. The light around you, the air in your lungs, the warmth in your skin, all of it is carried along by the motion of the universe. That motion has no center, because it is the center. Everywhere, even here, even now, time has always felt like a current, something you step into and drift along, with a beginning somewhere upstream and an end lost in the distance. It moves forward, steady and predictable, ticking through the patterns of your life. Sunsets, seasons, the slow curling of a leaf as it dries in autumn. But time is not a background feature. It's not a passive canvas that holds the universe together. It's part of the structure itself. And according to everything we know, it began, not as a moment inside the universe, but with the universe. The Big Bang wasn't an explosion in space. It was the birth of space, of time, of everything. A singularity, not of stuff crammed into a dot, but of geometry itself, curved beyond comprehension, until suddenly, from that infinite compression, came expansion. Space stretched, energy scattered, and time as we know it began to tick, not from some moment we can rewind to, but from a threshold beyond which the very concept of before breaks down. You might ask what came before the Big Bang. It feels like a natural question. Everything we know has a cause. Every fire needs a spark, every ripple a stone. But when we talk about the Big Bang, we're not looking at an event that happened in time. We're talking about the moment time itself began to exist. And if time began at that moment, then before becomes a question with no frame, like asking what's north of the North Pole. The coordinates don't extend that way. They simply end. This is where the mind pushes back. We want there to be something behind the curtain, a reason, a mechanism, a prelude, but physics doesn't offer one, not yet, and maybe not ever. General relativity tells us that as we rewind the clock toward the Big Bang, space-time curves more and more tightly until it reaches a point where the equations themselves no longer make sense. A boundary, a veil. Beyond that, we don't have math, we don't have language, we don't even have time. Some theories try to go further. They speak of quantum beginnings, of time bubbling out of a timeless state, of a multiverse where our Big Bang was just one ripple in a wider sea. Others imagine a bouncing cosmos, eternally collapsing and rebirthing, like a breath that never ends. But these ideas remain speculative, drawn from equations but not from observation. The truth is, we don't know. And perhaps we're not meant to. Not yet. What's more unsettling is that the universe may not need a reason. We are used to seeking causes. We build stories from them. But nature doesn't always follow our stories. In quantum mechanics, particles appear without known causes. Probabilities rule, not certainties. So maybe the universe didn't need a spark. Maybe it simply is, not because something lit the fuse, but because existence, in some form, was always possible. This isn't satisfying, not in the traditional way, but it is strangely beautiful. A cosmos that doesn't owe you a reason, a reality that arises not from need or design, but from possibility itself. A universe where time isn't a river flowing from the past, but a wave that rose from stillness and has been moving forward ever since. Even the way time works inside the universe is not what it seems. It bends, it stretches, it slows down near massive objects and speeds up in emptier space. Time near a black hole trickles by, seconds stretched into centuries. To an outside observer, it almost stops. And yet, to something falling in, time feels perfectly normal. This means that time is not a fixed, universal rhythm. It is part of the shape of the universe, just as curved and changeable as space itself. And still, somehow, it began. One moment, no seconds, no minutes, no past. The next, a future unfurling. This doesn't mean everything started fully formed. In those first tiny moments after the Big Bang, the universe was hot and dense and wildly chaotic. There were no galaxies, no stars, not even atoms, just energy and particles and a violent rush of expansion. But within that chaos, time flowed forward, entropy increased, structures began to emerge, and with those structures came the slow layering of complexity. Dust into stars, stars into elements, elements into worlds. All of this wrapped in time, not as a backdrop, but as a participant. Without time, nothing could change. Without time, there would be no now to drift through, no memory to hold, no unfolding of story or thought or breath. Without time, there would be no you. And so we are here, suspended in the middle of something vast, with time stretching out behind us like a shadow we can't fully retrace, and ahead of us like a road we can't fully see. Somewhere back there, 13.8 billion years ago, it started. We can't say what made it start, or even what made means in that context, but we know that it did. So what happens when we reach the edges of understanding? When the questions grow wider than the answers, we stop trying to force certainty into the gaps. We learn to sit with the mystery, to let it be what it is, a silence at the root of everything, a question that keeps unfolding without resolution. Time began, that much we know. But why? Maybe the universe doesn't owe us a why. Maybe it just is, quietly, steadily, gloriously becoming. There's a limit to what you can see, but not because the universe stops. The edge of your vision isn't the edge of reality. It's the edge of light. Light has a speed, and the universe has an age. That means there's only so far it could have traveled since time began. And so, when you look into the sky, you're not looking at space as it is. You're looking at what light had time to show you. Beyond that, the story continues, but the pages haven't reached us yet. This is what we call the observable universe. Not the whole thing, just the part we've had time to notice. A sphere about 93 billion light-years wide, filled with galaxies, filaments, background radiation, and silence. But the real universe could be far larger. It could be 100 times that size, 1,000. It could go on forever, curving gently into infinity, or looping back on itself in ways our minds struggle to imagine. And the truth is, we don't know. We can only build maps as far as light allows. We are explorers living inside an unfinished chart. The geometry of space holds the clues. It tells us how the universe is shaped on the largest scales. Is it flat, like an endless sheet? Curved inward, like the surface of a sphere? Or outward, like the saddle of a wave? Each shape changes the way light moves, the way gravity bends, the way parallel lines behave when stretched across billions of light years. And so, for decades, astronomers have studied that shape, not by touching its edges, but by measuring the subtleties in ancient light. That ancient light is the cosmic microwave background, a faint echo from the birth of the universe. It's not just beautiful, it's mathematical. Tiny fluctuations in temperature, patterns scattered across the sky, hold the fingerprints of geometry, and when we measure them, again and again, the same answer emerges. The universe appears flat. Not in the way a table is flat, but in a way that means, on the grandest scales we can observe, space doesn't seem to curve. A flat universe suggests something profound. That space might go on forever. That there is no edge, no wrapping, no returning. Just more, and more, and more. But flatness doesn't guarantee infinity. The universe could be flat and still finite, like a video game world that loops without borders, where traveling in one direction forever eventually brings you back to where you started, even if you never see a wall. And even if it is infinite, we are not. Our view is a bubble, carved by light and time. The cosmic horizon marks the farthest anything could have reached us, given the age of the universe and the speed of light. We can see 46 billion light-years in any direction, not because the universe is that size, but because that's the furthest distance light has stretched to touch us since the beginning. The galaxies beyond that boundary might exist. They probably do. But their light is still in motion, still traveling. It hasn't arrived, and it might never. Because space itself is expanding faster than light can cross it. Some places are retreating faster than signals can travel. They are not beyond space. They are beyond reach. This means we live inside a kind of moving frontier, a floating observatory in an ocean of dark. What we see today is not all there is. It's just all that's reachable for now. Tomorrow, a little more light will arrive. A little more past will become present. But some regions are already gone from view, not because they vanished, but because space has outpaced the light they sent. They are erased by distance, not by destruction. And what would it mean for the universe to be infinite? Infinite stars, infinite worlds, infinite versions of everything, not just once, but again and again, scattered across the boundless fabric of space. It's a thought that makes the mind stagger, not because it's certain, but because it might be. And if it isn't, if the universe is closed, curved like a sphere, then even that is beautiful. A universe that wraps in on itself like a whisper, endless in experience but bounded in form. We don't get to see the whole picture. Not now. Maybe not ever. Our instruments improve, our theories refine, but we're still mapping the cosmos from inside it. We send out light and wait for its return. We measure ripples and shadows. We guess at the shape of the infinite from the shape of the scene. The map is always partial, always growing, always a few steps behind the truth. But there's something quietly comforting in that. In knowing we live within a mystery too vast to complete. That there is always more beyond the horizon. More to learn. More to imagine. We stand on a planet orbiting a star, in a galaxy among billions, inside a sphere of visible space, wrapped in a silence that stretches forever, or nearly so. You are not at the edge. You are not at the center. You are simply within, and that's enough. The universe holds its shape, whether we understand it or not. It curves, or it doesn't. It ends, or it doesn't. But here, where you are, the stars still shine. The light still travels. The questions still unfold. And maybe that's what makes it so endlessly beautiful. Not the answers, but the reaching. Not the map, but the motion. Not the known, but the endless, quiet possibility of more. When you look into the night sky, what you see feels complete. Stars scattered like salt on velvet, planets tracing slow arcs, galaxies faint and shimmering in the dark. It feels full, almost crowded with light. But that light, every pinprick, every glow, every visible form, is only a trace, a fraction, an echo. All the matter we can see, touch, and measure directly, from every star in every galaxy to every atom in your body, makes up less than 5% of the universe. The rest is invisible, not hidden behind clouds or cloaked in shadows, but truly unseen. And yet, it's there. We know because of gravity. Galaxies spin, and they spin too fast, according to the visible mass, the stars and gas and dust. We should see them tear themselves apart. The outer stars move at speeds that can't be explained by what we can see, but they don't fly away. They stay in place, as if held by a ghostly hand. There is mass there, enormous and silent, exerting its pull with perfect patience. We call it dark matter, not because it's dark like shadow, but because it doesn't emit or reflect light at all. It's transparent to every wavelength, invisible to every telescope. But its gravity is undeniable. It holds galaxies together. It forms halos around them, vast and unseen. It binds clusters of galaxies in webs of force, stretching across the cosmos. When we look at how galaxies are distributed on the largest scales, we see patterns, filaments, walls, and voids. That structure didn't arise from the ordinary matter alone. It was shaped by dark matter, a scaffold beneath reality, arranging the visible like decorations on invisible bones. We've never captured a piece of it. We've never touched it, never held it in a lab, never seen it flicker in a detector with certainty. We infer it, like the presence of wind, by the movement of leaves. We map its influence. We watch how it bends the light from distant galaxies, distorting them slightly, subtly, as their beams pass through massive, invisible clumps of gravity. These distortions are real, measured, consistent. They trace the outline of something we cannot see. And still, dark matter is only part of the story. The larger share belongs to something even stranger, dark energy. Where dark matter pulls, dark energy pushes. It isn't mass, it doesn't clump. It flows, smooth and diffuse, filling all of space like an unseen pressure. We discovered it by accident, while watching ancient supernovae to measure how fast the universe's expansion was slowing. But instead of slowing, it was accelerating. Galaxies weren't just drifting apart, they were speeding up. And something was driving that acceleration. Something vast. Something everywhere. That's what we call dark energy. Together, dark matter and dark energy make up roughly 95% of everything, which means everything we've studied, everything we've built our science on, all the atoms and stars and gas and galaxies, it's all a sliver. A bright slice of something much larger and more mysterious. The universe is not mostly stars. It's mostly invisible. This challenges how we think about knowledge. We imagine the visible world as the foundation, the core. But what if it's only the foam on a deeper sea? What if the structures we cherish, the arcs of spiral galaxies, the arcs of our own thoughts, are shaped by things we can never directly perceive? It's humbling, but it's also thrilling. To know that beneath everything is a scaffolding of mystery, a silent architecture holding galaxies in place, shaping the evolution of stars, forming the pathways of light itself. Dark matter isn't just a curiosity, it's a framework. It shaped the early universe. Without it, structures wouldn't have formed. There would be no galaxies, no stars, no Earth. It's the quiet sculptor of the cosmos, and dark energy, for all its elusiveness, is even more fundamental. It dictates the fate of the universe. If it remains constant, the cosmos will continue to expand faster and faster until distant galaxies vanish from view. If it grows stronger, it could tear even atoms apart in a far future cataclysm. If it fades, gravity may once again take hold. We don't know. We can't predict the future with certainty until we understand this force that dominates the present. But perhaps the most extraordinary part is that we figured any of this out at all. With nothing but starlight and silence, we mapped a universe that hides more than it reveals. We saw the shadows cast by invisible mass. We measured the acceleration of expansion. We glimpsed the scaffolding behind the stars. And you, sitting here, are part of that same universe, made of the same matter as stars, surrounded by the same mysteries, suspended in the same invisible web. You are held by gravity you cannot see, moved by energy you cannot feel, and yet it is real. It is all around you. Sometimes it's enough to look up and wonder. Sometimes it's enough to know that the unknown is not empty, that invisibility is not absence, that even in the dark there is structure, there is force, there is form. Most of the universe is invisible, and still, it holds everything together. Black holes are not holes at all. They are not empty, not hollow, not tunnels through space. They are places where gravity has won, where matter has collapsed so completely that the fabric of space itself folds inward, pulled tight around a center that no one can see. A place where light cannot escape, where time does not pass the way you expect it to. A black hole is not the absence of something. It is the presence of everything, crushed into silence. At their boundary lies the event horizon, a surface not of matter, but of consequence. Cross it, and you cannot return. Not because something pulls you back, but because all paths forward lead inward. Even light, which normally travels freely through space, is bent inward here. Once it crosses the horizon, it cannot reach you again. That's why the edge is called what it is, a horizon of events. Anything that happens beyond it is lost to the rest of the universe, hidden forever behind a curtain you cannot see through, no matter how long you wait or how deeply you look. The gravity near a black hole isn't just strong, it's transformative. It doesn't merely tug at things, it bends them, it stretches space, it twists time. If you were to fall toward one, your body would experience something that sounds like fiction but is all too real. Spaghettification, a strange, clinical word for something horrific and magnificent. The difference in gravitational pull between your head and your feet becomes so extreme that you are stretched into a thin, fragile thread, atom by atom, molecule by molecule, drawn toward a singularity that does not forgive. But the more curious transformation happens to time. Gravity slows it. This isn't theory. It's been measured, even near Earth. The stronger the gravity, the slower time flows. And near a black hole, gravity is so intense that time nearly stops. To a distant observer, you would appear to fall forever, slower and slower as you approach the horizon, your last moments stretched across eternity. But from your own point of view, you would cross the edge quickly and silently, without fanfare, without resistance. You would fall inward, into the unknown, and you would never come back. Black holes are not rare. The universe is full of them. Some are the remnants of dead stars, compacted into darkness after lifetimes of burning light. Others, the supermassive ones, lurk at the hearts of galaxies, millions or even billions of times more massive than our sun. Ours has one too. At the center of the Milky Way, silent and invisible, a black hole waits. We know it's there because of how the stars move around it, fast and tight, like moths around a flame they cannot touch. Some black holes spin, and when they do more than consume. They stir the space around them, dragging it into rotation. This frame-dragging effect twists reality itself. In some cases, it creates violent jets of radiation and matter, shooting out from the poles like cosmic lighthouses. We see these jets across the universe, beacons from places we cannot peer into, signals from the edge of disappearance. And some black holes, when disturbed, sing. When two black holes collide and merge, they send ripples through space itself, gravitational waves, tiny distortions in the shape of the cosmos, like tremors on an invisible pond. These waves were predicted a century ago, but we only began to detect them recently, and what we found was extraordinary. Black holes vibrating, ringing like bells. The sound is not one you can hear with ears, but it is real. A wave in space-time, traveling at the speed of light, carrying the memory of something vast and irreversible. That ringing fades as the newly formed black hole settles, a final echo of an event no light will ever reveal. Black holes are not just strange, they are essential. They shape galaxies. They seed the growth of structure. They mark the end of stars and the bending of time. They are reminders that the universe is not bound by what seems possible, that the rules we know are stretched, pulled, twisted at the edges of understanding. And still, within that mystery, there is elegance. A black hole is not chaos. It is an extreme expression of order, of equations fulfilled too completely, of gravity taken to its purest form. And yet, for all their finality, black holes may not be the end. Some theories suggest that information, the details of matter and energy, cannot truly be lost, even inside a black hole. That somehow, what falls in is preserved at the edge, encoded on the surface, like a cosmic hologram. Others imagine that black holes evaporate slowly over time, losing mass through subtle radiation, shrinking until they vanish. If so, the universe is not just creating black holes, it is also erasing them, slowly and silently, over trillions of years. We don't know what lies beyond the horizon. We don't know what happens at the singularity, that place where our math fails and space curls into a point of infinite density. We don't know if black holes are gateways or tombs, if they are endings or beginnings. We only know they exist, that they bend the rules of space and time into forms we cannot yet understand, and that somewhere, right now, in the quiet dark between stars, they are spinning, singing, waiting, not empty, not gone, just hidden, behind a veil we cannot lift. There's something strange drifting at the edge of our galaxy. Ancient stars, dim and quiet, older than they should be. Stars that seem to carry the memory of a time before time, whispering tales from an age that shouldn't exist. When scientists calculated their ages, the numbers didn't just stretch the imagination. They broke the rules. Some of these stars appeared to be older than the universe itself. That can't be true. And yet, it was what the data seemed to say. The universe, according to our best understanding, began 13.8 billion years ago with the Big Bang. Space, time, matter, everything we know unfurled from that singular moment, expanding outward, cooling, coalescing. Stars didn't form right away. The first ones came a few 100 million years later, heavy with heat and light, igniting in a sea of darkness. But one of these peculiar stars, known by the unassuming name HD 140283, and sometimes called the Methuselah star, appeared to be 14.5 billion years old. That would make it older than everything, older than time itself. Of course, science is not quick to accept such contradictions. Paradoxes like this are not signs that the universe is broken, but that our understanding might be. And so astronomers went back to the numbers. They rechecked the distances, the brightness, the chemical composition. They recalibrated the models that translate a star's properties into its age. And slowly, the estimate dropped. 13.7 billion, 13.5, 13.2. Still old, astonishingly so, but no longer impossible. Not older than the universe, but nearly as old as the universe itself. The paradox didn't disappear completely, but it softened into something more human, a margin of error, a reminder that our measurements come with shadows. The age of the universe and the age of the oldest stars are close enough that small uncertainties can blur the boundary. Maybe the universe is slightly older than we think. Maybe the stars are slightly younger. Maybe the tools we use to peer into the past aren't as precise as we hope. And maybe that's okay. Because what these stars really offer us isn't contradiction. It's continuity. They are fossils of the cosmos, surviving remnants from the earliest generations. While most stars have lived and died and recycled their materials into new suns and planets, these ancient ones have remained, unchanged, untouched, preserved in the halo of our galaxy, far from the bustling spiral arms, floating in lonely orbits high above the galactic plane. They are not part of the bright, swirling disk where stars are born in great clouds of gas. They are watchers, drifters, witnesses to everything. Their composition gives them away. Unlike modern stars, which are rich with heavy elements forged in countless supernovae, these ancient stars are pristine. They contain almost nothing beyond hydrogen and helium, the original elements born in the furnace of the Big Bang. Their surfaces lack the fingerprints of generations. No carbon, no iron, no gold. Just the raw, untouched material of the cosmos before it grew complex. And so we call them population 2 stars, a term that feels clinical but hides something romantic. These stars are survivors from a time when the universe was young and empty, when the first galaxies were just beginning to form. They hold clues to the conditions of that time, not through photographs or memories, but through their light, their motion, their chemistry. They are time machines, each one carrying a piece of the early universe inside it. Some of them orbit alone, trailing long elliptical paths that take them far from the galactic center. Others are part of globular clusters, dense, spherical gatherings of stars that orbit like satellites. These clusters are among the oldest structures in the galaxy, and within them, the light of ancient suns still burns. Faint, steady, unchanging. And yet, even these stars are not eternal. Their fuel will one day run out. Their cores will cool. They will fade into darkness, leaving behind white dwarfs or collapsing into something even smaller. But right now, they burn on, quietly, patiently. They have seen the galaxy grow around them. They have outlived countless civilizations. They have drifted through ages of fire and silence, never stopping, never looking back. They remind us that age in the universe is not measured by decay or wear, but by distance from the beginning. That something can be unimaginably old and still shining. That the past is not lost. It's still out there, flickering softly in the dark, if you know where to look. So when we find a star that seems too old, too strange, too early, we aren't seeing a mistake. We're seeing the limits of our knowledge. We're seeing the edge of understanding, and we're seeing a kind of beauty that lies in imperfection, in the unresolved, the uncertain, the nearly impossible. Because the truth is, the universe doesn't owe us simplicity. It doesn't tidy itself to fit our models. It leaves behind questions like footprints and expects us to follow them. And sometimes, those footprints lead to a quiet, ancient star, drifting at the edge of everything, whispering a story from the dawn of time. From a great distance, galaxies look like whirlpools of light, graceful, quiet, suspended in darkness. But they are not frozen. They are moving, turning, sliding through the fabric of space on paths set in motion billions of years ago. Some drift alone, undisturbed. Others fall together, drawn by mutual gravity, pulled into slow embraces that take hundreds of millions of years to unfold. These are not sudden crashes. They are dances, patient and silent, choreographed by forces too vast to feel. Right now, our home galaxy, the Milky Way, is drifting toward another, Andromeda, the nearest spiral neighbor. From our perspective, it looks like a faint smudge in the night sky, visible from dark places if you know where to look. But it is enormous, beautiful, and coming closer. In about 4 billion years, the two will meet, not like two stones smashing together, but like two clouds slowly merging. Their halos will touch first, then their outer arms will begin to intertwine. Over time, the cores will spiral into one another, circling, merging, changing. And yet, despite the scale of this cosmic collision, the stars within each galaxy will not crash into each other. They will pass by like strangers on an empty street, distant and unaware. The reason is space. Vast, silent space. Galaxies are made of stars, but stars are separated by such enormous distances that even when galaxies collide, the stars within them almost never do. It's like throwing two handfuls of sand at each other from across a football field. Most grains will simply pass through. So when galaxies collide, it's not the stars that shatter. It's the structure. The shape of the galaxy warps. Arms are pulled into long tidal tails, stretching like ribbons behind the core. Streams of stars are flung outward, caught in gravitational currents. The orbits of stars shift. Clouds of gas are compressed, triggering bursts of star formation. New stars are born in the wake of collision, brilliant and brief. But the stars themselves, most of them simply move, finding new paths, new homes, new dances. The Milky Way and Andromeda will not be destroyed when they meet. They will become something new. A larger galaxy, likely an elliptical one, rounder and slower spinning. For a while, there will be chaos, twists of dust, waves of light, clumps of stars thrown into eccentric orbits. But the end result will be calm again. A new structure, a new balance, a new place where stars will continue to shine and planets may still circle in peace. This idea that something so massive, so transformative, can happen without violence is both surprising and beautiful. We expect collisions to bring destruction, but on this scale, the rules change. Gravity doesn't always shatter. Sometimes it shapes, sometimes it rearranges. Even now, we see evidence of these encounters across the sky. Some galaxies have long, trailing arms, tidal remnants of past collisions. Others show warped disks or twisted cores, signs of ancient mergers. We see galaxies with twin nuclei, still in the process of fusing. We see shells of stars surrounding elliptical galaxies, faint ripples from the ghosts of devoured companions. The universe remembers its collisions, not with scars, but with shape. And yet, in the quiet heart of all this motion, stars continue to burn. They do not know they are being flung across new orbits. They do not feel the pull of another galaxy drawing near. A star may begin its life in one spiral arm and end it drifting through the remnants of a merged core. But to the star, it is all the same. It shines, it ages, it fades. The galaxy moves around it. Sometimes, in these collisions, new opportunities arise. Gas clouds compressed by gravitational tides may ignite new generations of stars. Some of these stars will live short, brilliant lives. Others will last for billions of years, carrying the legacy of their creation into the deep future. Entire planetary systems may be born in the aftermath, carrying with them the history of a galactic dance that took place long before. And here on Earth, we are watching. From inside one of the galaxies that will one day merge, we can't feel it. The stars above still hold their patterns. The constellations seem steady. But the dance has already begun. Andromeda is approaching, slowly, silently. Its motion barely noticeable on human timescales, but relentless. It is not a threat. It is a story in progress, one we are lucky to witness. There is something comforting in this kind of transformation, a reminder that not all change is catastrophic, that sometimes things fall together instead of falling apart, that the universe, in its vastness, allows for motion without collision, change without destruction. It allows for stars to live through the reshaping of their home, and for beauty to emerge from movement. Galaxies collide, but stars endure, not untouched, but unbroken, rearranged, not erased. And so, 4 billion years from now, if Earth or its descendants still exist, the night sky will look different. The familiar band of the Milky Way will be transformed, expanded, entangled with new stars from a galaxy once far away. A sky filled with strange patterns, brighter lights, deeper shadows, a new view, a new home. The result of a dance that began long before we could see it. And through it all, the stars will continue to shine. Long before there were people, before oceans or languages or even planets, there were stars. And in the deep hearts of those stars, something miraculous began. Under immense pressure and heat, simple atoms fused. Hydrogen, the lightest of all elements, was pressed into helium, then into carbon, then into oxygen, iron, and beyond. Each fusion a small act of creation, each one shaping the raw material that would one day become everything else. Stars are not just lights in the sky. They are alchemists, forging the elements of the universe in silence and fire. The calcium in your teeth, the oxygen in your lungs, the iron in your blood. None of it was present in the earliest moments of the cosmos. The Big Bang made hydrogen and helium, and not much more. Everything else, every atom heavier than those first two elements, was born inside stars, created in their cores over millions or billions of years, then released back into space in a final, brilliant gesture. Some stars swelled and shed their layers gently. Others exploded in supernovae, scattering their contents across light years of emptiness. It's through that scattering that the universe began to recycle, to evolve, to build. Your body is not a separate thing from this process. It is the result of it. You are, quite literally, made of star stuff. Not in a poetic way, but in a physical, elemental sense. The carbon that forms your cells was forged in a long-dead star. The nitrogen in your DNA once lived in the heart of a sun. The atoms that make up your thoughts, your memories, your hands, they are ancient. They drifted for ages through the galaxy before finding their way into you. This isn't just a metaphor. It's physics. It's chemistry. It's astronomy. It's the quiet truth behind your existence. The atoms that form you have been part of other things. Oceans, rocks, creatures, clouds. Before that, they were suspended in gas and dust, floating in interstellar clouds. And before that, they were inside stars. You are not separate from the universe. You are the universe, rearranged. The journey of an atom is long. It begins in fusion, small nuclei merging under extreme heat. In stars like our Sun, fusion produces helium. In more massive stars, the chain continues, building up to heavier elements. But there's a limit. Iron, once formed, marks a kind of threshold. It can't be fused further without costing more energy than it gives. And when enough iron builds up in a star's core, a reckoning arrives. Gravity wins. The star collapses inward in a blink, then rebounds in an explosion so powerful it can outshine entire galaxies. A supernova, a cosmic death that is also a cosmic birth. In that explosion, the conditions are violent enough to form the heaviest elements: gold, uranium, lead. These are not everyday processes. They happen in seconds and only in the most extreme places. But they happen, and when they do, those elements are hurled across space. They mix into clouds of gas and dust. They enrich the raw material of the galaxy. And over time, that material gathers again, pulled together by gravity into new stars, new planets, new chances. Earth is one of those chances. Our planet was born from a cloud already rich with recycled stardust. The early solar system was filled with collisions and heat and chaos. But amid that chaos, something stable emerged. A rocky planet in the temperate zone, with water, with atmosphere, with the ingredients for life. And eventually, those ingredients organized themselves into patterns. Molecules, cells, organisms. And those patterns became aware. They became us. So when you breathe, when you move, when you dream, you are not doing so as a visitor to the universe. You are a continuation of it, a way for it to look back on itself. You are not an outsider looking in. You are a piece of the cosmos that knows it exists. And this process hasn't stopped. Stars are still dying. Supernovae still light the darkness. New stars still form. The cycle continues. Some atoms inside you today may one day become part of another planet, another creature, another story. You are part of the ongoing experiment of existence. It's easy to feel small in the face of all this, to look up at the stars and think of yourself as a dot, a speck, a moment. But consider what you're made of, the ancientness of it, the journey each atom took to become you. That's not small, that's profound. You are not just in the universe is in you. Not symbolically, not metaphorically, literally. And the stars that gave you their pieces, many are gone now. Their light has faded, their cores have cooled, but the gift remains. You carry their memory in your bones. You are the echo of their fire, their final act of creation, living on as a body, a mind, a voice, living on as a question, as a song. And when you're gone, you will return to that cycle. Your atoms will drift again. They will find new homes, new shapes. The story will continue, written in stardust, not erased, just rewritten. This is not just science. It's intimacy on a cosmic scale, a connection deeper than imagination. And it's true. It's quietly, unshakably true. If you could somehow turn down all the noise of the present, silence the rustle of wind, the hum of machines, the distant call of birds, the murmuring of your own thoughts, and listen, really listen, past the veil of now, you might still hear it. A whisper, faint and steady, not in any language, not in words at all, but in temperature, in light. A sound not carried through air, but through the very fabric of space. It is the echo of everything that began. The universe hums. Not like a song with melody or rhythm, but like a quiet thermal glow, spread across the cosmos in every direction. The cosmic microwave background, CMB, as scientists call it, is the oldest light we can see, the faint afterglow of the Big Bang itself. It has been traveling for nearly 14 billion years, crossing the expanding universe, thinning and cooling, stretched by time until its wavelength is no longer visible to our eyes, but still very much present. A microwave whisper from the dawn of time. When the universe was young, only a few 100,000 years old, it was hot, dense, and opaque. Light couldn't travel freely then. It scattered off electrons like headlights in thick fog. The universe was glowing, but it was blind to its own light. Then, slowly, it cooled. Electrons and protons found each other, forming neutral atoms, and suddenly, the fog lifted. Light could move, it could stretch out and wander. That moment is called recombination. But you might think of it as the first time the universe exhaled. The CMB is that breath, still traveling. It's everywhere. If you point a sensitive enough radio telescope at any patch of sky, between stars, beyond galaxies, you will find it. A faint signal, just 2.7 degrees above absolute zero. A nearly perfect blackbody spectrum, uniform almost to the extreme, but not entirely. Because in that soft sea of ancient light, there are tiny variations, ripples, really, like fingerprints left on a window. Those ripples carry the seeds of everything: galaxies, stars, planets, you. All of it began with those fluctuations. Small differences in density, amplified by gravity, pulled matter into clumps and filaments, and the great cosmic web we see today, all from the quiet static of the background. This light is not bright. You can't see it with your eyes. But it's so pervasive that 1% of the static on an old television tuned to a dead channel comes from it. That fuzz, that flickering nothingness. It's not all noise. Some of it is the sky itself, remembering how it began. The first map of the CMB came from a satellite called COBE in the 1990 seconds. It was grainy and rough, but it confirmed what had long been suspected. The Big Bang wasn't just a theory, it left evidence. A few years later, the WMAP mission sharpened the view, revealing a cosmos speckled with structure. And later still, the Planck spacecraft gave us the clearest picture yet, a map of the entire sky as it looked just 380,000 years after the beginning, before stars, before galaxies, before anything had a name. It's hard to grasp what that map really is. Not a photo in the traditional sense, but a thermal imprint, a temperature chart of a time when the universe was nothing but a soup of particles and radiation. The mottled patterns show us the infant cosmos, swaddled in heat, just starting to settle into the shape of everything to come. When we look at the CMB, we are looking not across space, but across time, the farthest past visible. There is something haunting about that. The idea that the universe carries its own memory, like a low hum, a steady signal that never turns off. It reminds us that time isn't just something we move through, it's something etched into the world itself. The past doesn't vanish, it stretches, and this stretching tells us more than just the age of the universe. The CMB also reveals its shape, its fate. The way the temperature fluctuations are arranged tells us the geometry of space itself. Whether the cosmos is curved like a sphere, saddle-shaped, or flat like a vast plain, all evidence so far suggests it's almost perfectly flat, infinite perhaps, unbounded, or close enough that any curve is beyond our ability to detect. The hum also tells us about what the universe is made of. By analyzing its delicate structure, scientists have been able to infer the proportions of dark matter, dark energy, and ordinary matter, a recipe written in radiation, a fingerprint from fire. And still, despite all this, the CMB is remarkably silent. It does not shout, it does not flash, it waits, patient and unchanging, spread across the vault of space like an old memory. Even now, as stars are born and galaxies collide, as black holes spin and planets bloom with oceans and dust, the microwave background remains. It fades, ever so slowly, as the universe expands and cools, but it is still there. It will be there long after the last star dies, long after the last light goes out, a final ember glowing in the darkness. Sometimes, when you look up at the night sky, it feels like you're staring into stillness, but you're really staring into motion, into echoes, into something ancient that never quite went away. The universe hums, and if you listen closely, you can almost hear it. Right now, as you sit wherever you are, more than 60 billion particles are passing through every square centimeter of your body every single second. You don't feel them. You don't see them. They leave no mark, no warmth, no trace you can notice. They slip through your skin, your bones, your blood, through the earth itself, and then keep going, untouched and untouching. These are neutrinos, ghost particles, as they are sometimes called. Particles that exist almost in secret, passing through the universe like whispers between stars. They were born in fire. In the fusion reactions at the heart of the sun, where hydrogen becomes helium and light is made, neutrinos are also made. Countless numbers of them, flung outward at nearly the speed of light. But the sun is not their only cradle. Neutrinos come from the death throes of stars, from supernovae that collapse and explode with unimaginable force. They are born when atomic nuclei decay, when cosmic rays strike the atmosphere, even in the deepest reaches of space where galaxies collide and black holes feast. They are born in silence and travel in silence. Almost every second of your life has been spent bathed in this invisible tide, and despite their abundance, they are profoundly elusive. Neutrinos barely interact with matter because their mass is almost non-existent, and their charge is nothing at all. Most of the time, they simply pass through everything. Through walls, through oceans, through entire planets. 1 trillion of them can pass through your fingertip in a heartbeat, and the chance that even one will hit an atom is almost zero. But sometimes, just rarely enough, they do. And when they do, they leave a mark that lets us know they were there. To catch a neutrino is an act of patience and scale. Scientists build vast detectors in deep underground chambers, using enormous tanks of water or ice or heavy liquid. These places are shielded from the noise of other particles, protected by miles of rock or Antarctic ice. They wait in darkness for the rare moment when a neutrino collides with something, when a particle that almost never touches anything finally touches, and when it happens, there's a flash, a brief flicker of light, like a fingerprint of the invisible. The discovery of neutrinos was not easy. They were first proposed in the 1930 seconds to explain missing energy in radioactive decay. Something strange was happening. Something seemed to be vanishing. To account for it, physicist Wolfgang Pauli suggested a particle so shy, so non-interactive, that it had evaded detection entirely. It wasn't until decades later that we confirmed they were real. And even now, understanding them remains one of the most difficult tasks in physics. They change identities mid-flight, flipping between different forms. Electron, muon, tau, as if undecided about what they are. No other particle does this. It's as though they exist in motion, in ambiguity, in question, and yet they are everywhere. Created by fusion in the heart of the sun, they stream out in all directions, filling the solar system in a constant flood. They arrive on Earth just 8 minutes after being born, faster than any signal, more direct than any message. Every second, trillions pass through you. They are remnants of distant explosions. Messengers from the beginning of time. Some may even be older than stars, older than light itself. They carry with them the memory of creation, and they move through space like it isn't even there. They do not illuminate, but they inform. By studying them, we learn about what lies beneath the visible. We learn about what powers the sun, what happens in the heart of a dying star, what filled the early universe when it was still too young to cool. Neutrinos are time travelers. They don't stop, they don't scatter, they don't fade. They arrive unchanged from places we can't reach by any other means. They are, in a strange way, the universe's most honest witnesses. And still, for all their movement, all their presence, they are silent. You will never know they pass through you. They do not alter your day. They do not weigh you down. They don't care what you're doing or where you are, but they are always there, brushing past your atoms with the lightest possible touch. It's almost poetic, the idea that so much of the universe flows through us constantly and leaves us exactly as we were. We live with it, and yet, apart from it, there is something humbling in their presence, something that reminds us how much of reality exists beyond our senses. We like to think of ourselves as observers, as participants, but most of what happens in the cosmos will never register to us. It continues whether we see it or not. The neutrinos are proof of that. Unseen but real, passing through everything, speaking to us without words. And perhaps, in their way, they say something about connection. Not the kind we recognize through speech or sight or contact, but a deeper kind. A constant, invisible thread tying everything to everything else. Born in fusion, in collision, in death, traveling across unimaginable distances, entering stars and bones and oceans without distinction. They treat all things the same. And that, too, is beautiful. So tonight, as you rest, as your breath slows and your thoughts drift, know that the neutrinos will continue their journey. They will pass through your pillow and the ground beneath it, through forests and cities and mountains, through oceans and clouds and hearts. They will continue through the earth and out the other side, untroubled, unchanged. The universe is not silent. It just speaks in a language we've only begun to understand. Neutrinos are part of that language, a soft whisper, barely there, and yet always present. A reminder that the world is more than what we see, more than what we feel. It is full of things that pass through us without asking, things that speak, even when they leave no trace. Time is not what it seems. You live your whole life, assuming it flows evenly, predictably, like a river moving forward in smooth motion. You wake, you breathe, you grow older. A minute is a minute. An hour is an hour. But that's only how time feels here, on the surface of this small blue world, within its gravity, under the pull of Earth's constant presence. Out there, in the emptier spaces between stars, or deep in the wells carved by massive bodies, time behaves differently, not metaphorically, literally. Time stretches, time slows, time bends. Einstein showed us that space and time are not separate things, but part of a single fabric, woven together in a pattern called space-time. Where matter exists, that fabric curves, and where it curves, time changes. Gravity doesn't just pull on mass, it pulls on the pace of existence. The stronger the gravity, the slower time ticks. This isn't poetic exaggeration. It's been measured. It's real. There is a clock on a satellite orbiting Earth right now that ticks more slowly than a clock on your nightstand. Just a little, just enough to measure, just enough to matter. If GPS satellites didn't account for this difference, this gravitational time dilation, your location could be off by miles, not because their data is wrong, but because their time is. And if you go higher, farther from Earth's grip, time runs faster. Move closer to a massive object, and it slows again. Near a black hole, it stretches so much that it almost stops entirely. A minute for someone orbiting near that edge could be hours for someone far away. If you stayed near the event horizon, suspended in that stretched frame of time, and then returned to Earth, you might find years had passed, decades. You would have moved through time at a different speed. This is the essence of the twin paradox, a thought experiment that explains the strange consequences of special relativity. Imagine two twins. One stays on Earth. The other boards a ship that travels close to the speed of light. Time on that ship moves more slowly. When the traveling twin returns, they are younger than their sibling, not by illusion, not by trick of the mind, but by physical reality. One has aged more than the other. You don't have to be near light speed or a black hole for this effect to happen. It's happening now, in small ways. Your head is aging slightly faster than your feet. Time moves differently for the International Space Station than it does for you. The faster you move, the more time slows for you relative to someone standing still. These are not glitches or bugs. They are built into the nature of the universe. Time is not a metronome, ticking identically everywhere. It is flexible. It responds to movement, to mass, to energy. It flows faster or slower, depending on the shape of space around it. It has texture. It has stretch. And yet, from within your life, it doesn't feel that way. You don't notice the shifts. The seconds still come, one after the other, in a rhythm your body understands. You measure your days in sunrises and sleep cycles, in meals and seasons and memories. But beneath that familiar cadence is something stranger, something that defies intuition. Your experience of time is local, specific, tied to your gravity, your speed, your position in the fabric. Someone else, somewhere else, could live the same moment differently. This realization opens something wide in the mind. If time is not absolute, if it is shaped by where you are and how you move, then the idea of now becomes slippery. What is present for you may already be past for someone else, or still the future. The universe does not synchronize its clocks. It allows each path, each journey, to keep its own time. And yet somehow, in all this fluidity, you exist. You grow. You remember. You hope. You move through your days without feeling the bend, even though it's there. Even though the very seconds you live are stretched by mountains and softened by speed. It means that time is not a ruler we impose on the universe. It is a property of the universe itself. And like all properties, it reacts. It changes. It can be twisted and warped by the shape of reality. Time is not a constant stream you float in. It's a terrain you travel through. It has hills and valleys. It has tight turns and wide plains. And you, like every particle and planet and photon, are riding the curves. Somewhere, light is leaving a star that no longer exists, traveling through stretched-out time, unchanged by the death that lies behind it. Somewhere else, in the pull of a massive galaxy cluster, time is slow enough to echo. The past lingers longer there. Gravity holds on to it a little more tightly. And maybe, far into the future, someone will orbit the edge of a black hole for what feels like minutes, only to return and find civilizations have risen and fallen. There's a kind of softness in this, a reminder that time does not hurry. It does not rush to conclusions. It lets the cosmos unfold at different tempos, depending on where the song is being played. And you, here, now, resting in a moment that seems still, are part of that music. Your time is not wrong. It's not broken. It's just yours, defined by where you are in the dance, by how the universe cradles your tiny patch of space-time. So as you lie here, breathing slowly, let yourself imagine the stretch. Picture time as something that breathes with you, sometimes quick, sometimes slow, sometimes tight, sometimes vast. Let go of the idea that it's fixed. It isn't, and that's what makes it beautiful. In the beginning, a star is not yet a star. It is a cloud, cold, dark, unformed, a drifting expanse of gas and dust, spread thin across the emptiness, waiting in silence. But gravity is never idle. It tugs gently, persistently, folding the cloud in on itself. Over millions of years, the cloud tightens. What was once still begins to stir. Pressure builds. Heat accumulates. At the center, a spark is born. Not of fire, but of fusion. Hydrogen atoms collide and merge, releasing energy, and the cloud lights up from within. A star opens its eyes. For most of its life, a star exists in balance. Outward pressure from fusion pushes against the inward pull of gravity. This equilibrium is delicate, but it holds. The star shines steadily, faithfully, pouring energy into space during this long middle phase, what astronomers call the main sequence. The star is like a beating heart, pulsing for billions of years. The sun, your sun, is in this phase now, warm and bright and stable. But stars are not eternal. Eventually, their fuel begins to run low. Hydrogen becomes helium. Helium becomes heavier elements. The fusion slows. The balance begins to tip. Gravity starts to win. A star nearing the end of its life changes. It swells, enormous and unstable, becoming a red giant. Its outer layers balloon outward. Its core contracts. For a time, it grows brighter, stranger, more dramatic. But this is not a renewal. It is a farewell. Small stars, like the sun, will shed their outer layers and leave behind a core no larger than Earth. A white dwarf, glowing with the heat of all its remembered life. It will shine for a long time but no longer burn. And eventually, even that faint light will go out. More massive stars end differently. When their cores can no longer support the weight of all they've become, they collapse. The inward rush is sudden, unstoppable. In a fraction of a second, matter is crushed, and the star implodes. What follows is violence, the explosion of a supernova. The outer layers are hurled into space, seeding the galaxy with elements born in the star's final moments. Gold, silver, uranium, metals forged in fire and flung like cosmic ash. What remains at the core depends on the star's mass. If it is heavy, but not too heavy, it becomes a neutron star, a city-sized object with the mass of the sun, spinning rapidly, dense beyond comprehension. Its gravity is immense, its surface solid and strange, its magnetic fields intense enough to sweep beams of radiation across space like lighthouse beams. These are pulsars, ticking in the dark. But if the star was massive enough, there is no neutron star. There is no surface left at all. The collapse continues until nothing, not even light, all can escape. A black hole is born, not an object, but a boundary, a place where space and time fold so tightly around themselves that they vanish into something we cannot see, cannot touch, cannot fully understand. This might seem like an ending, but in the language of the universe, endings are not so simple. The death of a star makes new things possible. The elements scattered in a supernova become parts of planets, parts of people. The heavy metals in your blood, in your bones, were once locked inside a star that lived and died before Earth existed. And even black holes may give rise to new ideas, new theories, new frontiers, new questions. Still, there is something quietly melancholic in the fate of stars. No matter how bright, no matter how long they burn, they all come to an end. And as time stretches out, billions, trillions of years, the stars begin to fade. First the biggest go, then the medium ones. Then, slowly, the small red dwarfs, burning their fuel so sparingly that they may outlast the galaxies themselves, but not forever. There will come a time, far beyond your imagining, when the last star flickers out, when the last fusion reaction ends, when the universe, once ablaze with light, becomes cold and dark. This future, this long, slow fade, is not something you need to fear. It is a truth written into the fabric of space, a gentle truth, not cruel, just inevitable. And yet, in that truth, there is beauty. Stars do not vanish without a trace. They leave behind trails of light that travel across the cosmos, echoing their presence long after they're gone. A star you see tonight may already be dead, its photons still on their way to you. Light, in this sense, is memory, a record of what was. You are part of this cycle, not apart from it, but within it. The calcium in your teeth, the iron in your blood, the carbon in your cells, they are relics of stars. You are, quite literally, stardust held together by gravity and time. Every breath you take is flavored by the ancient sky. So when you look up at night, remember that you are not just looking at stars, you are looking at ancestors. at the makers of matter, at the engines of creation, at the sources of all light and warmth. And you are also looking at destiny, at what will come and what will pass and what remains. Stars don't shine forever, but while they do, they make life possible. They paint the darkness with color. They sing in radiation, pulse in brightness, collapse in silence. Their story is long and luminous, and it lives on in everything. Even you. There is a version of the universe, perhaps, where this moment doesn't exist, where you never pressed play, never lay down, never asked the question that set this quiet night in motion. There may be another you entirely, thinking other thoughts, walking other paths, living out a life that split from yours long ago, or just now, or never at all. It sounds like science fiction. But it isn't, not entirely. It's a whisper from the edge of physics, a gentle suggestion from the math that governs reality, that the universe you know, the stars, the galaxies, the laws of nature themselves, might be only one thread in a much larger tapestry, one bubble in an infinite foam, one version of everything, floating in a sea of what-ifs. The idea is not born from fantasy, but from need. Some theories, when followed to their logical ends, don't stop with one universe. They demand more. Inflation theory, the one that explains the Big Bang's sudden, overwhelming expansion, predicts that once inflation begins, it doesn't just end everywhere all at once. It ends here and there, in patches, in bubbles, and each bubble becomes a universe. Ours is just one. Outside it, others keep forming, each with their own physics, their own rules, their own strange skies. The multiverse, in this version, is not a choice. It's a consequence. Then there's quantum mechanics. At the smallest scales, particles do not behave predictably. They behave probabilistically. An electron is not here or there. It is here and there, until we look, and the possibilities collapse into one. But some interpretations say the possibilities don't collapse. Instead, reality splits. Every quantum decision, every branching path, creates a new universe. One where the electron went left, one where it went right, one where you stayed, one where you left. In this view, the multiverse is branching constantly, endlessly, into a fractal of realities, where everything that could happen does. And if there are other universes, other versions of reality, they may be profoundly different. Some may have no stars. Some may be ruled by gravity so strong that matter never had a chance to spread out. Some may have more dimensions, curled up tightly or sprawling wide. Some might have versions of you in them, or nothing even close. You wouldn't feel these other universes pressing against yours. There is no known bridge, no tunnel, no window to look through. But if they exist, they change the way we think about this one. Because if there are infinite universes, then the improbable becomes inevitable. A universe with just the right conditions for life becomes not miraculous, but expected. Somewhere, in the vast elsewhere, everything happens. Not once, but always. Every story is written. Every star is born. Every silence hums with possibility. But possibility is not the same as proof. And here is where the mystery deepens. These multiverse theories, as elegant as they may be, are almost impossible to test. We cannot step outside our universe to compare it to another. We cannot observe the branching paths of quantum decisions. We can only follow the equations. We can only look at the sky and wonder if we are alone, not just in our galaxy, but in our reality. Still, the idea lingers. Not because we want it to be true, but because it solves problems that no single universe seems to answer. It offers a frame large enough to contain all the strangeness, all the fine-tuning, all the odds that stack too neatly in our favor. Why does the universe allow life at all? Why do the constants of nature seem so perfectly arranged? Maybe because they're not arranged for us. Maybe because there are countless other places where life cannot be. And this is simply one of the rare ones where it can. But more than that, the multiverse speaks to something deep and ancient in the human mind. The yearning to believe that the world is not all there is, that behind the stars, beyond the edge of what we can see, more waits, more stories, more chances, more selves, even if you never meet them, even if they are forever unreachable. It invites the imagination to drift, not wildly, but carefully, into the idea that existence is not a single thread, but a weave, that you are not a singular point, but part of a greater pattern, that reality, like a forest, is thick with paths that vanish into the dark, each one as real as the one you chose. And if that is true, then what does it mean to be here, in this version, listening now? Does it make you small, to be one of countless variations? Or does it make you precious, to be this you, with this night, in this body, in this breath? You are not less because others might exist. You are not a copy, not a shadow. You are still the only one living this particular thread. This is still your chapter. Maybe there are others, maybe not. The universe doesn't say. It only offers clues, patterns in the background noise, equations that lean toward infinity, simulations that suggest other realms might make sense. It is not a confirmation. It is a question. And sometimes, questions are enough. So as you lie there, letting the thoughts settle, let it stretch your mind, but not overwhelm it. Let it expand softly, like a dream that continues beyond waking. You don't need to understand the whole multiverse. You don't need to prove or disprove. You just need to know that the universe, your universe, is wider and stranger than it appears. That even now, as you rest, the story continues, branching quietly, blooming invisibly into all the other ways it might have been. There are planets that drift through the darkness with no sun to warm them, no star to orbit, no morning or evening to mark their days. They wander the galaxy alone, not in rebellion, but in quiet detachment. These are the rogue planets, worlds without homes, without orbits, without light. They move through space like forgotten thoughts, like dreams that slipped free from the minds that shaped them. Not broken, not wrong, just untethered. We don't know how many of them are out there, maybe billions, maybe more. Some may have formed in isolation, born not from the swirl of dust around a star, but from collapsing gas clouds too small to ignite. Others were likely cast out, ejected from young, turbulent solar systems, flung into interstellar exile by the gravity of their siblings or the reckless motion of cosmic debris. A planet, once nestled near a newborn sun, could be shoved too hard, too fast, and suddenly it's alone, slipping beyond the gravity that once held it close. And once it's gone, there's no coming back. Out in the void, a rogue planet keeps going. There is no resistance in space, no friction, no end. These planets could drift for billions of years, crossing the galaxy in slow arcs, unseen and mostly unfelt. No sunlight touches them, no moons circle them. Their skies are not blue, not golden, not anything. They are black, pure black, pierced only by the distant light of stars they do not know. Still, these planets are real. They are not just mathematical curiosities or speculative maybes. We've found signs of them. Gravitational nudges, brief lensing effects when they pass in front of background stars. We've caught glimpses of their shadows, their influence, their passing weight, but they're hard to see. They don't reflect light, like planets in orbit do. They don't glow. They don't shout. They whisper. And yet, there is something deeply haunting and beautiful about them. A planet without a star sounds like a tragedy, a world cut loose from the warmth that gives it life. But not all life depends on sunlight. On Earth, deep below the ocean floor, life persists in complete darkness, feeding on heat and chemical energy from within the planet itself. Bacteria thrive near hydrothermal vents, far beyond the sun's reach. Entire ecosystems bloom in the abyss. So maybe, just maybe, a rogue planet could host life of its own. A thick atmosphere, insulating heat from a molten core, subsurface oceans, warmed from below, strange forms of biology, slow and alien, evolving under pressure and silence. Life that never sees a sky, never knows day or night. Life that dreams only in black, and maybe not. Maybe they are frozen through, solid ice from pole to pole, cold beyond imagining, places where even molecules barely move. But even so, they are part of the story, part of the cosmic experiment. Proof that not every world needs a sun to be a world. We call them rogue because they don't follow the rules we're used to, because they drift outside the structure of what we know. But that name, rogue, carries a kind of dignity too. They are not failed planets. They are not mistakes. They are possibilities. Their journeys are their own. And who's to say what such a journey means? If a planet orbits nothing, is it lost, or is it simply free? It's hard to picture. From here, Earth feels so full, so busy, so bright. Days filled with light, nights with stars, seasons that mark the slow turn around the sun. We are tied, completely, to our star. We live in its orbit, rely on its energy, mark our lives by its movement. The idea of a world with no such anchor feels strange, almost wrong. But space does not require symmetry. It does not ask that every system be familiar. It allows for wild variance. And in that variance, it leaves room for these drifting worlds. Lonely, yes, but also serene. Suspended in quiet, moving endlessly forward, with no need for destination. And perhaps one day, we will visit them. Perhaps a distant probe, sent across centuries, will glide past a rogue planet's atmosphere, scan its surface, peer beneath its crust. Or perhaps we will learn to read their stories from afar, listening to the subtle warps in starlight, the way ripples reveal a swimmer just beneath the surface. Each rogue planet a message in a bottle, thrown into the sea of space, waiting for someone to find it. Or perhaps they will always remain just out of reach. Too faint, too dark, too far. That's all right too. Some mysteries aren't meant to be solved. Some are meant to be kept. To remind us that the universe is wide and wild and filled with silence. And even in that silence, there is meaning. So tonight, as you lie there, imagine a world wrapped in ice, drifting through a place where light never comes. Imagine winds brushing over alien mountains, frozen oceans stretching beneath a sky that never changes. Imagine a heartbeat, maybe, deep below the crust. Or maybe nothing at all. Just stillness. A world with no sunrise. No orbit. No name. But still a world. Still moving. Still part of the great unfolding. For a long time we thought gravity was instantaneous. That if the sun vanished, Earth would feel it immediately. The tug gone all at once, as if space itself could update in real time. It seemed intuitive. Gravity was always just. But there. Not a force that traveled, but one that simply was. Constant, silent, unchanging. But the universe doesn't work that way. Einstein showed us that. Gravity, he said, is not an invisible hand reaching across space. It's the shape of space itself. Massive objects. Stars, planets, black holes. Don't pull. They bend. They curve. The fabric of reality, and other objects move along those curves. It's not a tug, it's a slope. And when something massive shifts suddenly, when two black holes collide, or a star collapses, space doesn't just rearrange itself quietly, it ripples. Like a stone dropped into a pond, the disturbance spreads outward in every direction. Those ripples are gravitational waves, not waves in space, but waves of space. Space stretching and squeezing, subtly but truly, as the wave passes through. And here's the strange, precise part. They travel at the speed of light. No faster, no slower. Exactly as fast as the photons that carry every color we see, every signal we send, every echo of every ancient star. Gravity, too, is a messenger, a ripple that respects the same cosmic speed limit. This was a bold idea, once. Just math, just theory. But in 2015, we heard it. Two black holes, far beyond our galaxy, had spiraled toward one another for eons, each tens of times the mass of our sun, locked in a gravitational dance too perfect and too violent to last. As they circled faster, closer, tighter, the space around them distorted more and more. And then, in a final moment, they merged. The collision was silent. There was no flash, no light. Just movement, just mass changing shape. And that change rippled out. Over 1 billion years later, that ripple brushed past Earth. It passed through you, through everything, unnoticed. The distortion it caused was unimaginably small, less than the width of a proton, but not zero. Detectors built with impossible precision, interferometers stretching kilometers, felt it. The instruments quivered. Space itself had moved. It wasn't just a triumph of engineering. It was a moment of profound confirmation. That space is not still, that gravity moves, that Einstein, again, had seen truth hidden in equations. For the first time in human history, we weren't just seeing the universe, we were hearing it, because gravitational waves are soundless, but they act like sound. They carry rhythm, shape, echo. When translated into audible frequencies, they chirp. When two black holes merge, the wave rises in pitch and amplitude like a bell being struck harder and harder until it rings its final note. That's what we heard. A faint, perfect chirp from the fabric of the cosmos itself. It changed everything. We had opened a new sense. Just as telescopes let us see further, gravitational wave detectors let us feel deeper, into places light cannot reach, into collisions that produce no glow, into histories written not in fire, but in motion. Since then, we've heard more. Neutron stars crashing, more black holes merging. Space doesn't just ripple once, it ripples constantly. Like the surface of an ocean beneath the stars, the universe shivers with memory. And it humbles us, because those waves are not just theoretical. They touch us, not metaphorically, but physically. They pass through your body, through your bones, through the very atoms that make you. They compress and stretch space itself, not by much, not in a way you feel, but in a way that matters. You are moving, constantly, through a sea of invisible tides. It means that nothing is ever truly still. Even here, even now, in this quiet moment as you breathe, the room around you is gently shifting, not by its own will, not by any breeze, but because somewhere in the universe, something immense has moved, and the echo of that motion has found its way here. And these ripples do more than stir space. They confirm something profound about time, that cause and effect are not immediate, that gravity obeys the same constraints as light and thought, that even the fundamental structure of reality has patience. The sun could vanish, and for 8 minutes, we would still orbit its memory. This delay, this slowness, is not a flaw. It is the shape of the rules. It keeps the universe honest. It ensures that no information, no signal, no influence ever outruns the speed that light and gravity are bound to. It is part of the symmetry, part of the poetry. Space can stretch and dance, but it cannot cheat. So the next time you think of space, don't picture emptiness. Picture a living, trembling medium, a stage that responds when its players move. Not passive, not void, but vital. Every galaxy, every collision, every shift of weight sends whispers through the dark. Not because anyone is listening, but because the universe cannot help but speak. And we, brief and small, have learned to hear just a little of it. We've tuned our instruments to the cosmic lullaby, and for a moment, we are no longer just spectators. We are participants in the rhythm, aligned with the pulse of black holes, touched by waves that began long before our species did. It's easy to forget that the ground beneath us is not fixed. That space, the thing we move through, is itself in motion. But it pulses, it sings, it remembers, and when it does, it reminds us of our place. Not at the center, not in control, but within it all. Floating on a current of curves and echoes, listening to the soft, relentless voice of gravity, moving exactly as fast as light allows. At the heart of our galaxy, hidden behind clouds of dust and star-swarmed silence, there is something vast and invisible. It does not glow, it does not shimmer, it does not speak, but everything in the Milky Way moves because of it. The stars that spiral in perfect arcs, the gas that drifts, pulled but never caught, the orbits that last billions of years, all circling one central unseen weight, a black hole, immense, ancient, quiet. Its name, as far as names go, is Sagittarius A*, a designation that says very little about what it truly is. 4 million times the mass of our Sun, compressed into a region no larger than the orbit of Mercury. Not a star, not a planet, not even a thing in the way we usually understand things. It's a place in space where gravity has taken over completely, where light cannot escape, where time distorts, where the known dissolves into the unknowable. And it is not unique, not rare, not a galactic exception. Almost every galaxy we look at, with tools sharp enough and eyes steady enough, shows the same secret: a supermassive black hole resting at its center like a dark heart. Not a parasite, not a destroyer, a keystone. This is one of the quietest revelations in astronomy, that these monstrous singularities, these points of no return, might be essential. That galaxies don't just happen to have black holes, they may need them. The formation of a galaxy may not be possible without one. In the early universe, matter gathered into dense knots, gas collapsed, stars were born, and somewhere in the middle of that swirling chaos, black holes formed and grew. And as they grew, they shaped everything around them. But here's the strange part. For something defined by its silence, by its refusal to emit light, a black hole can also be one of the brightest beacons in the universe. Not because the hole shines, but because of what happens around it. When matter falls toward a black hole, gas, dust, even stars, it doesn't fall straight in. It spirals, it heats up. It collides with itself, creating a disk of unimaginable energy. In these swirling infernos, particles accelerate to near light speed, temperatures climb into the millions of degrees, and light pours out. X-rays, gamma rays, radiation across the spectrum. If enough matter is feeding this hungry center, the result is a quasar. Quasars can outshine their entire galaxies. They can be seen from billions of light years away, bright enough to be visible when the universe was young. For a time, these black holes become lighthouses, blazing in the dark, before their fuel runs out and the glow dies back down into stillness. It is one of the strangest ironies of the cosmos, that something born from collapse, from the end of light, can also become the engine of brightness, that the darkest places are the ones that teach us the most about illumination. Our own galaxy is quieter now. Sagittarius A times is mostly resting. Occasionally, it flares. Small outbursts as bits of matter fall in and vanish. But for the most part, it waits, it turns, it keeps the stars around it in check. Our solar system orbits the galaxy at a safe distance, far from the grip of the center, but not untouched. We are part of that great swirl, that ancient dance, shaped in ways we rarely feel. And it's not just a feature of now. These black holes, these gravitational titans, have histories. Some grew from the remains of the first massive stars, others from collisions, mergers, accumulations over time. When galaxies merge, their central black holes spiral toward each other, drawn by mutual gravity, until eventually they collide, forming an even larger one. These mergers send out gravitational waves, ripples in space, subtle but real, announcing that something massive has changed. There is a story written in these centers, a story of beginnings and endings, of heat and cold, of light and shadow, of the paradoxes that seem to define the universe, where destruction becomes creation and absence becomes presence. Because a black hole is not a hole, it's not a void, it's a region where gravity has written its own laws, a threshold beyond which we cannot see, but not beyond which all meaning ends. The space around a black hole is active, dynamic, alive with motion, and even the event horizon, the point where escape becomes impossible, is not a wall, but a surface with texture and consequence. And in this way, these central black holes are not just destinations, they are engines. They regulate star formation, they shape the distribution of gas. They carve the structure of galaxies across billions of light years. Their influence is subtle but profound. They don't rule by force, they rule by gravity. They do not need to shine. The universe remembers their presence anyway. So tonight, as you lie still beneath the atmosphere of your small world, try to imagine the center, not just of the galaxy, but of every galaxy. Imagine a place so heavy, so perfectly curved that not even light can leave. Imagine a thing that shines by consuming, that shapes by pulling, that reveals itself only through absence. And then imagine that this thing is not evil, not violent, not unnatural, just ancient, just essential, a part of the structure, the same way your heart is part of you, necessary, steady, silent. The galaxy turns around it. So do we. When you look up at the stars, you're not seeing them as they are now. You're seeing them as they were, the light that reaches your eyes, in gentle, flickering, timeless. It has traveled across unimaginable distances, carrying with it memories from deep in the past. Each point of light is a messenger, and every glance at the night sky is an act of time travel. You are not simply observing space, you are peering through time itself. This is one of the quiet truths the universe whispers when you're still enough to listen. The farther away something is, the older the story it tells. Because light, for all its speed, 186,000 miles per second, is not instant. It moves fast, but it still takes time. A star 10 light-years away is not 10 light-years distant only in space, but also in time. You are seeing it as it was 10 years ago. Multiply that by hundreds, thousands, millions, billions. The night sky becomes a museum of moments, frozen in flight. Some of the stars you see tonight have already died. They've exploded in brilliant supernovae or quietly collapsed into embers and dust. But their light, faithful and constant, keeps going. It crosses the dark, indifferent void to reach you long after its source has gone silent. There's something strangely comforting in that, a kind of cosmic echo, proof that presence can outlast origin. If the sky were quiet, if space were a perfect vacuum in every way, erasing all signs of what once was, you'd look up and see nothing. No stars, no galaxies, no past, just darkness. But instead, the night sky glows with stories so old they predate everything we've ever known. Stories that began when Earth was molten, when life didn't yet have a name, when time itself was still stretching its legs. Some of the light you see tonight has been traveling since before there were humans to see it, before there were cities, before there were oceans teeming with fish, or forests crawling with insects, before music, language, or the quiet rituals of sleep. You are the first listener in a very long chain to receive these signals. You, lying there in the dark, are part of an ancient conversation, and the farther you look, the younger the universe becomes. This might sound backward, but it's one of the paradoxes that makes space so strange. When you look into the deepest depths, the faintest galaxies, the most distant quasars, you are seeing them not as they are now, but as they were shortly after the beginning of everything. You're glimpsing a universe still soft with youth, still expanding, still cooling, still forming stars for the first time. Telescopes are not just lenses, they are time machines. They let us peer into the early chapters of a story still being written. With each advance in technology, we go deeper and deeper still. The James Webb Space Telescope, suspended beyond the moon's gravity, has already begun showing us infant galaxies whose light has been traveling for over 13 billion years. These are not nearby neighbors. These are fragments of a dawn we were never meant to see, and yet, somehow, we do. And if the night sky is a time machine, then every photon is a passenger. Each tiny particle of light carries information about the temperature of a star, its age, its composition, its motion. These delicate messengers arrive at Earth's edge, having avoided dust clouds, gravitational pulls, and cosmic storms. They arrive battered but intact, the final witness to events long past. It makes you wonder what else is out there. What sights are just now on their way, streaking toward us across the void? What ancient catastrophe or celestial birth is currently en route to our waiting eyes, not to arrive for another 1,000 years? There are explosions happening right now that no one will see for ages. There are beginnings unfolding in silence, destined for someone else's future sky, and you are part of this too. Your body emits light, though it's invisible to your eyes. Your warmth ripples through the air. The atoms that make you once absorbed starlight and now reflect it in small, secret ways. You are made of things that once burned in the hearts of stars and cooled in the shadows of nebulae. You are not separate from the story the night sky tells. You are one of its latest chapters. Sometimes we forget this. We go about our days, distracted by the noise and glow of artificial lights, rarely looking up. The sky becomes background, the stars become static. But every so often, something reminds you. A quiet night, a power outage, a walk in the countryside, that the sky above you is not just scenery, it is history, unfolding in reverse. And it's not just beautiful, it's deeply humbling, because when you see the light of a star, you're not just seeing brightness, you're seeing persistence. You're seeing something that left its home long before your home existed, something that crossed the endless dark without complaint, without pause, just to fall gently onto your retinas and disappear into meaning. So tonight, lie still, let your eyes adjust, let your breath slow, and when you feel ready, let your gaze drift upward. Pick any star. Imagine its light racing toward you through the silent vacuum, year after year, age after age. Imagine all the events it passed by, all the galaxies it skimmed, all the cold nothingness it pierced, and know that you, here and now, are the end of its journey. You are the witness it's been waiting for. Out in the darkness, far beyond the edges of our solar system, and deeper still into the spiraling arms of distant galaxies, something strange is happening, something that shouldn't be possible. Stars, those immense furnaces of fire and fusion, are circling the hearts of their galaxies faster than gravity should allow. They're racing along like dancers on a carousel that forgot to slow down, holding tight to curves that, by all rights, should fling them into the void. And yet, they remain, spinning, steady, as if tethered by invisible threads. It was a quiet discovery at first, a curiosity buried in the data. When astronomers began measuring the speeds of stars at different points within galaxies, they expected to find a pattern. Stars near the center should orbit quickly, drawn close by the heavy concentration of mass, while those farther out should drift more slowly, their gravitational leash looser, their motion gentle. But the universe didn't follow the rules. Instead, stars far from the galactic center were whipping around just as fast as those nestled near the core. It was like watching planets orbit a sun that wasn't there. This wasn't a mistake in math. It wasn't a glitch in the telescope. It was a whisper from something unseen, something massive, something everywhere. Dark matter, a name that's more placeholder than explanation. It isn't dark in the way shadows are dark or night is dark. It doesn't absorb light or block it or even bend it the way stars and planets do. It simply doesn't interact with light at all. It is invisible in the truest sense, undetectable by any form of radiation we know how to observe. You could be surrounded by it right now and never know. And yet, we're almost certain it's there, because the things we can see are behaving as if they're caught in its grip. It holds galaxies together. Without it, they would unravel, their stars flung like sparks from a firework, drifting apart forever. But with dark matter, this invisible scaffolding, everything holds. It cradles the luminous matter we can see, shaping it, guiding it, stitching the universe into the form we know. In a way, dark matter is more reliable than the stars themselves. The visible parts of galaxies are messy and bright and burning with drama, but dark matter is calm. It doesn't collapse into stars or explode into novas. It doesn't shimmer or flare. It just exists, silent, massive, persistent. It surrounds galaxies in vast halos, stretching far beyond the outermost stars, enveloping them in gravity's hush. And it's not rare. In fact, if our current understanding is even close to right, then everything we've ever seen, all the stars, all the planets, all the glowing clouds of gas and dust, all the comets and moons and bright nebulae, makes up only a tiny fraction of what's really out there. Less than 5%. The rest is dark energy and dark matter, with dark matter alone accounting for nearly a quarter of the universe. That means most of the universe, the vast majority, is composed of something we cannot see, cannot touch, and do not fully understand. Yet we feel its pull. We see its fingerprints in the way galaxies cluster, in the way light from distant galaxies bends around invisible masses, distorting and magnifying like a lens. We trace its presence through simulations that only make sense when dark matter is added to the mix. It's like trying to solve a puzzle with missing pieces, and then realizing the empty spaces are part of the picture too. And if that's true, if the universe is built atop a foundation we cannot perceive, then what else might be waiting just beyond our reach? We don't know what dark matter is made of. It might be composed of exotic particles that rarely, if ever, interact with ordinary matter. It might be something we haven't even imagined yet, something beyond the standard model of physics, beyond the frameworks we've built to make sense of the cosmos. It might even be a hint that our understanding of gravity is incomplete, that space itself moves in ways we don't yet comprehend. But whatever it is, it's not absence. It's presence without light, influence without appearance. A quiet actor on the grandest stage, shaping galaxies with a touch that leaves no trace, only consequences. It makes you wonder, how many things in life, beyond science, beyond space, are like that? Invisible forces shaping visible outcomes. Feelings that go unspoken, but steer our choices. Memories that don't shout, but still echo. Connections that endure even when nothing seems to hold them. There is something tender in that thought, that not everything that matters must be seen to be real. Somewhere, billions of light years away, a galaxy is spinning. Its arms are outstretched like a whirlpool of stars, and its brightest lights are dancing at its very edge, defying gravity's known laws. And we, from here, can watch that defiance and know there is something more holding it all together. Not because we can see it, but because we see what would fall apart without it. We live in a universe that hides more than it reveals, where the unknown isn't a barrier, but a path. So tonight, as you lie beneath the stars you can see, think for a moment of the stars you can't. Think of the galaxies whose hearts are cradled in silence, held in the embrace of something utterly invisible and yet utterly essential. Think of the hidden strength that moves through the cosmos, quietly shaping everything. And then, gently, let yourself drift, knowing that even the unseen can be trusted to hold you. In the stillness between now and forever, the universe hums a quiet question. How does it all end? Not the end of a single life, or a star, or even a galaxy, but everything. The whole of existence, space, time, motion, light. Will it go suddenly, in a brilliant collapse, or will it stretch into an eternal hush, unraveling into silence so slowly we barely notice until all that remains is memory? The truth is, no one knows for sure. Not even the most powerful minds, not even the best equations. But we have glimpses, like shadows flickering against the far wall of time. There is one idea, soft and cold, called the Big Freeze. It begins not with an explosion, but with a drifting apart. The universe, ever expanding, continues to stretch, galaxies pulling away from one another like flecks of light on a rising tide. Gravity weakens, stars grow old, new stars struggle to form. The furnaces that have lit the cosmos for eons sputter out, one by one, until even the last red dwarf fades into blackness. It won't be dramatic, it won't be fast, it will be quiet, slow, and cold. A deep chill that settles over everything, as entropy, nature's quiet, unraveling, reaches its endgame. Entropy isn't destruction, exactly. It's the spreading of energy, the soft equalization of everything. It's a cup of coffee going cold, a balloon slowly deflating. The universe, it seems, is trending toward equilibrium, and equilibrium is silence. In this future, light no longer travels because there's no one to see it. Time still exists, but there's nothing left to change. No contrast, no spark, no distinction between here and there, now and then. Just a vast, dark plane of low-temperature particles drifting in a silence too large to echo. And yet, this isn't the only ending we've imagined. There is also the Big Crunch, a vision of reversal. Instead of expanding forever, the universe might one day begin to contract. Gravity, long outpaced by dark energy, could regain its grip. Galaxies would slow in their retreat. They'd begin to drift back toward each other, slowly at first, then faster, collapsing inward like a great cosmic breath, exhaling. Stars, planets, everything would race together until space itself folds in on itself, shrinking, tightening, heating, converging into a point as dense and hot as the very beginning. A final inferno. A universe in reverse, ending in the same fire from which it was born. If that happens, maybe time loops. Maybe another bang follows. Maybe we've been here before, and we will be again. But there's a third idea, stranger than both, the Big Rip. In this vision, the expansion of the universe doesn't slow or settle. It accelerates. It grows wild. Dark energy, mysterious and persistent, becomes more than a backdrop. It becomes dominant, untamable. Galaxies tear away from each other faster and faster. Then, stars pull away from galaxies. Planets pull away from stars. Molecules break from molecules. Eventually, even the very atoms that make you would come undone. Not with heat or cold, but with sheer force, with space itself, stretching faster than anything can hold together. This would be the fastest ending, and the loneliest. Nothing crashes, nothing collapses. Everything is simply separated, torn apart by the fabric of the cosmos unweaving itself. And yet, even in the face of these ends, there is beauty, because endings are only meaningful if there is something that came before. Light that was born, stars that sang, life that wondered. There is something peaceful in imagining the universe, not as something that explodes or crashes, but as something that sighs. that slips away the way a song does, its final notes drifting into memory. If the cosmos ends in silence, it will be a silence earned through eons of radiant brilliance. In the very last moments of the Big Freeze, there may still be motion, black holes slowly evaporating, releasing their final breath of energy into an almost perfectly empty sky. The last spark, the final whisper. Then, even those will be gone, leaving behind only the darkness that cradled everything. But before that, for now, there is light. There are stars still forming, galaxies still spinning, minds still asking questions. The universe is not at its end. It is still growing, changing, stretching. It still dreams through us, looks at itself through our eyes, listens to its own echoes with instruments we built from the same elements forged in its first fires. We are not yet in the silence. We are still in the song. So tonight, as you close your eyes, let your thoughts drift out past the orbit of the moon, past the warm breath of the sun, past the swirl of stars and the glowing arms of the galaxy. Let them drift toward the edge of what we can see, where time thins and light ages, and possibility begins to blur. Out there, far beyond the veil, the future of everything is waiting, not fixed, not certain, but unfolding. Will it end with a bang, a whisper, a tear? Maybe none of these, maybe something else, something stranger. Whatever comes, it won't be an erasure. It will be a transformation, a turning of the page on a story too vast for a single ending. And until then, we are part of that story. Each thought, each question, each gaze at the night sky is a thread in the fabric of a universe still becoming itself. A universe that began in fire, burns still in the hearts of stars, and may one day sleep in silence, having said all it had to say. A lullaby of light, fading gently into the dark, tucked away in a gentle curve of the Milky Way. Earth drifts quietly through a region of space few maps bother to emphasize. Not one of the grand spiraling arms, not near the galactic core where stars crowd so closely they blur into a haze of light. We live in the Orion Spur, a minor branch, an in-between place, neither here nor there, a cosmic side street compared to the bright boulevards of star formation and chaos. It might sound unremarkable, it might sound lonely, but in the deep, dangerous architecture of galaxies, this kind of quiet is a blessing. The Milky Way is not just a beautiful swirl of stars. It is also a machine. Its arms are not merely decorative. They are active, roiling regions where gravity pulls matter into dense knots, igniting stars, birthing clusters, and sometimes ending them in violent collapse. Supernovae blaze in those places like sudden fireworks, casting out radiation strong enough to sterilize whole star systems. And yet, here we are, orbiting gently within the calm outskirts, just far enough from danger to survive, just close enough to witness the grandeur from a safe distance. Our position matters more than it seems. Earth is about 26,000 light-years from the galactic center, far enough that we avoid the intense gravitational tides and supermassive black hole that churns restlessly at the heart of the Milky Way. The radiation there is fierce. The stars are older, more crowded, their fates tangled together. Life, if it exists in those central realms, would live under a more volatile sky, a sky that doesn't sleep, a sky that rarely forgives. Out here in the Orion Spur, we enjoy a sort of cosmic suburbia, not entirely empty. There are stars around us, of course, and nebulae, and the occasional dying sun. But there is space to breathe. We're not jostled by neighboring stars, not constantly reshaped by collisions. The pace is slower, the noise is lower. It's this silence, this relative stillness, that allows complexity to grow undisturbed. Life needs time, it needs calm, it needs stability. And we have, so far, had all three. Perhaps that's the real miracle. Not that Earth formed in the first place, not that life arose, not even that consciousness bloomed in the mind of a fragile species, but that it happened here, In this sliver of the galaxy, at just the right distance from the core, in just the right lull between storms, we often talk about the habitable zone of a star, the Goldilocks range where water can be liquid, where temperatures are not too hot or too cold. But perhaps there's also a galactic habitable zone, a region where cosmic conditions don't constantly reset the clock, where explosions are rare and radiation is low, where, improbably, a blue planet can evolve thought and memory and meaning. And the beauty is, we didn't know. For most of human history, we looked up at the sky and imagined ourselves at the center, not just of our world, but of all worlds. The stars circled us. The heavens bowed to us. And yet, when we finally built the tools to see farther, to map the spiral arms and trace the structures of galaxies, we discovered the truth. We are not central. We are not perched in a privileged throne. We are out on the edge, peeking in. But maybe that's what made us who we are. Maybe this quiet vantage point gave us room to ask questions instead of constantly dodging catastrophe. Maybe being far from the noise gave us time to listen, to wonder, to grow slowly, to tell stories. Because here, the silence is not emptiness, it's opportunity. The Orion Spur may not be famous. It may not be dense or bright. But its quietness is exactly what makes it rare. We orbit a calm star in a quiet region on a planet that has remained surprisingly stable for billions of years. There have been mass extinctions, yes. There have been ice ages and impacts and upheavals, but the planet itself has held together, spun reliably, warmed us with sunlight, and cooled us with ocean winds. And all the while, the galaxy has gone on whirling, dancing its ancient rhythm, without ever noticing our tiny presence. Maybe that's what makes the silence so precious. The fact that it isn't guaranteed, that it isn't permanent. There could be a gamma ray burst tomorrow from some unseen explosion light years away. There could be a rogue star drifting toward us, or a molecular cloud that nudges our sun just enough to stir its outer layers. The universe is not safe. It is not serene. But right now, this arm, this tiny offshoot of a grander spiral, is letting us be, letting us think and feel and build telescopes and write lullabies to the stars. We live in the pause between galactic heartbeats, and even if it doesn't last forever, even if the silence one day breaks, we were here, we listened, we noticed. So tonight, as you settle beneath a sky that has always seemed quiet, remember that the silence above you is not accidental. It is the sum of millions of lucky chances, each one stacking atop the other, until a planet formed in a safe orbit, in a stable system, in a quiet spur, within a galaxy that spins but does not shake us. You are not in the center, but you are held by a spiral arm that bends softly through space, by a lull in the cosmic storm, by the hush that let the universe pause long enough for someone to ask what it all means.